What is it that astronomers have found using our new $10 billion toy? It will be years before that project becomes a reality. If it goes as planned, the journey to Proxima b will take about 20 years, so realistically, it will be several decades before we can confirm if there is indeed life on that planet. The age-old question, are we truly alone in this universe? The James Webb Telescope has discovered some terrifyingly human-esque things far, far away from Earth that lead us closer to the answer. Our search for life outside of us has been rampant throughout each human civilization, so much so that we have thousands and thousands of media literature and theories on this subject. Our wonder regarding our place and loneliness in the universe has been constant, as if it is ingrained inside of us to always search for a companion, no matter how alien-like. Well, we just might be getting closer and closer to the answers we truly want. But are they truly the answers we are looking for, or are they much more terrifying? Join us as we explore the latest discovery in the realms of galaxies and planets on the quest to find something we just might not be prepared to witness. Lights far, far, far away, scientists have discovered what could be the most groundbreaking discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting hypothetical question was raised about the capabilities of our technology. The question was whether in the future our telescopes could detect artificial light on another planet. For example, Proxima b, the closest exoplanet to Earth, is in the habitable zone of our nearest neighbor, the dwarf star Proxima Centauri, about 4.25 light-years away. Since the exoplanet was 20 times nearer to its star than the Earth is from the Sun, Proxima b was believed to be tidally locked with a permanent day side and night side. This is similar to our Moon, which faces Earth with the same side at all times. A hypothetical technological civilization on Proxima b might transfer heat and electricity from the day side to the night side using photovoltaic cells that generate electricity out of starlight. Subsequently, in a paper with Manas V. Lingam as one of the researchers, it was shown that significant coverage of the day side by solar panels could be detected with future telescopes. Since JWST was more advanced, it would allow us to extend our search for artificial lights to habitable exoplanets like Proxima b. Now in 2024, it is possible that the James Webb Space Telescope did just that. Using its higher sensitivity and bigger range of capabilities, the JWST might have discovered the lights we were looking for and possibly hurled us into another big surge of human evolution. But first, let us dive into the world of planets and exoplanets to learn how all this was even possible. James Webb's mission explores Proxima Centauri b's secrets. Throughout history, humans have wondered about the nature of the universe. What we are, where we come from, and where we go are common yet extremely difficult questions man has tried to answer as soon as he gained consciousness. Now in the age of exponential technological advancement, one does wonder if we are any closer to any of the above questions. If you would ask a philosopher, he would probably say we are still at level 0 of understanding ourselves and the universe. However, ask an astronomer the same thing and watch him jump up and down in excitement as he rushes to tell you the latest discovery humans made about the universe using their nifty tools. These tools, although not paid much attention to by the average public, are quite literally a manifestation of human evolution itself. We now have the world at our fingertips, and it is time we move forward and get the universe at our fingertips as well. One such way to do that has been deduced by scientists and astronomers. It is through the technology we harness. A specific creation of that said technology is now responsible for the recent discovery of what might be light on a different planet light-years away. Yes, we're talking about the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the legacies of human expeditions into space to answer some ever-present questions. Are we alone? Who is out there? Where do we begin and where do we end? Well, this infrared astronomy tool has already begun answering these questions, although partially. Well, first you might find yourself asking what even is Proxima b. Proxima Centauri b, or just Proxima b, is sometimes referred to as Alpha Centauri cb. It is a super-Earth exoplanet, and it orbits an M-type star. Super-Earth exoplanet, M-type star confused yet? Do not worry, since this video will quell all of your burning questions. Super-Earths are a class of planets that are more massive than Earth, yet lighter than ice giants like Neptune and Uranus. They are truly one of a kind. They can be made up of gas, rock, or even a combination of both, and their sizes can vary from twice the size of Earth all the way to 10 times its mass. They really put the super in Super-Earth, huh? As for Proxima b, it is a super-Earth and an exoplanet. meaning that it is a planet that traverses outside the solar system. The very first possible evidence of an exoplanet was found in 1917, although it managed to stir up little curiosity and recognition. However, in 1992, the first confirmed detection occurred, which left scientists speechless. Another exoplanet, a different one, which was first detected in 1988, was confirmed in 2003. As of the 1st of April 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These marvelous discoveries are orbiting an M-type star right now. To explain the M-type star, you need to understand the red dwarf. A red dwarf is the smallest kind of star in the main sequence, hence the name. In the neighboring regions of the Sun, red dwarfs are by far the most common type of star to be found in the Milky Way. They have really low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to observe. The sneaky stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of 3900 K, hence getting their name and attributes. Coming back to Proxima b, its mass is known to be equivalent to 1.07 Earths. Interestingly, it only takes 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can estimate the size of the star Proxima b is orbiting. Staggeringly, under the measurement of the entire electromagnetic spectrum, the star has a total luminosity of only about 0.16% that of the Sun. Additionally, in the visible light spectrum, its luminosity seems to dull even more as it appears fainter. It only illuminates 0.056% of the Sun's luminosity in the visible light spectrum, emitting a significantly less amount of light energy when compared to the Sun. Over 85% of its emitted energy is in the form of infrared radiation. Orbiting about 0.048560 away from its star, Proxima b's discovery was announced way back in 2016. You might be wondering why Proxima b? Millions of stars, planets, and galaxies, so why are we so fixated on this particular celestial body? Well, there are a few reasons that contribute to the keen interest astronomers have in this place. First and foremost, Proxima b is the closest known star to our Sun and by definition us. Although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a mere blip. Hence why Proxima b, our closest known star, is high up on the priority list. At the moment, it is also a part of the triple star system called Alpha Centauri, and although Proxima b's luminosity is very low, the system itself appears as one of the brightest constellations in the night sky, only behind two others called Sirius and Canopus. However, the most interesting thing about Proxima Centauri b is that it might potentially be habitable. Since it falls under the habitable zone, the possibilities surrounding this star are endless, and thus astronomers have taken on the expedition to explore the depths of limits of the potential of this star. That is where the James Webb Space Telescope comes in. The four key goals of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, understand star and planet formation, and to study planetary systems and the origins of life. As the JWST continues its exploration of the said exoplanet, we get closer and closer to the completion of these missions, from SETI to exoplanets, searching for alien life. So, what exactly is SETI, one might ask? Considering that humans have always been a curious species, poking and prodding into literally anything and everything that moves and doesn't move, it makes sense that a quest like SETI came into existence on such a large scale. Imagine that God has organized a grand cosmic treasure hunt, but with a twist. Instead of gold, we are tasked to be on the lookout for signals, more specifically electromagnetic whispers from civilizations beyond our wildest dreams. SETI is short for Search for Extraterrestrial Intelligence, and it is our collective effort to detect signs of intelligent life lurking amidst the stars, our faithful comrades in this cosmic journey. Radio telescopes, optical instruments, and an unquenchable thirst for knowledge and possibly new friends or foes from the depths of the universe. SETI dates back to the 19th century when the early seeds of curiosity were sown, but it truly blossomed in the 20th century with advancements in radio astronomy. The notion that we could eavesdrop on cosmic conversations was a tantalizing prospect. Scientists began scanning the skies for artificial signals, looking for patterns that nature alone could not produce. This endeavor is fueled by a profound realization. If intelligent life exists elsewhere, it might be detectable through the electromagnetic energy they unwittingly or deliberately emit. Picture tuning into a celestial broadcast, hoping to catch an interstellar soap opera or a news update from a distant civilization. SETI embodies our cosmic curiosity and the longing to connect with others in the vastness of the cosmos. We are listening for radio waves, peering at optical flashes, and analyzing vast amounts of data for that telltale sign, a message from another world. Think of it as the universe's grand puzzle, where each piece is a clue, and we, the diligent solvers, are determined to find the missing fragments. Fast forward to the age of the James Webb Space Telescope, and our tools have become even more sophisticated. The JWST, with its remarkable sensitivity and range, offers us a window into the cosmos like never before. Its capabilities go beyond detecting radio signals. It can identify potential biosignatures, the telltale chemical signs of life, in the atmospheres of exoplanets. Imagine finding a planet with a signature similar to Earth's, where oxygen, water vapor, and other life-sustaining elements are present. The JWST brings us closer to this reality, enhancing our search for extraterrestrial intelligence. This telescope allows us to peer into the atmospheres of distant worlds, hunting for the chemical footprints of life. As we detect more exoplanets and gather data, the dream of discovering alien civilizations becomes less of a fantasy and more of a scientific pursuit. The potential discovery of artificial lights on Proxima b by the JWST could be a groundbreaking moment in this quest. If these lights are confirmed, it would signify that we are not alone, that there are other beings out there who have harnessed technology and perhaps even yearn for connection just as we do. This discovery would not only be a scientific milestone, but also a profound moment for humanity, challenging our perceptions of ourselves and our place in the universe. As we continue our cosmic search, armed with the JWST and other advanced tools, we inch closer to the possibility of answering one of the most profound questions of all time. Are we alone in this vast, mysterious universe? What has astronomy uncovered with our latest technological marvel, costing billions? The journey to confirm its findings will span decades due to distance. Realistically, we're decades away from verifying the existence of life on distant planets. Are we truly alone in the universe? This question, ancient yet persistent, drives humanity's relentless pursuit beyond our skies. Documented across millennia in literature and theory, our curiosity about our place in the cosmos persists, an innate search for companionship, however alien. We may be nearing answers we've sought, but are these revelations what we truly desire, or are they more unsettling? Join us as we delve into the latest galactic and planetary discoveries in pursuit of truths we may not be prepared to confront. Lights discovered in the distant reaches may herald our most profound breakthrough. Back in 2021, speculation arose about detecting artificial light with future telescopes. Proxima b, orbiting our nearest neighbor, Proxima Centauri, tantalized researchers with its potential. With the James Webb Space Telescope's advanced capabilities, detecting COF technology on such habitable exoplanets became feasible. Now, in 2024, the JWST may have delivered, potentially propelling us into a new phase. What have scientists unearthed with our latest $15 billion endeavor? We're looking at decades before this initiative becomes tangible. If all goes according to plan, the journey to the outer reaches of our solar system will take approximately 25 years. Realistically, we may not confirm the outcomes until much later. The perennial question persists: are we truly alone in this vast cosmos? Our fascination with extraterrestrial life spans epochs of human history, reflected in countless literary works and theories. The search for companionship beyond our planet is a quest ingrained in our very being. We might be on the verge of answers we crave, yet are they the revelations we seek, or something more unsettling? Join us as we delve into the latest breakthrough in the realms of cosmic exploration, where distant lights may hold the most profound discoveries in history. Back in 2023, when our cutting-edge mission was slated for launch, speculation arose about the capabilities of our technology. Could our instruments one day detect traces of ancient civilizations on a distant celestial body? For instance, the Kuiper Belt, a region rich in primordial matter, might harbor clues to our solar system's early history. Fast forward to today, our pursuit of knowledge has borne fruit. Through advances in quantum mechanics and particle physics, we've pushed the boundaries of what we thought possible. As we look ahead, we may discover even more about the origins of life, from the smallest particles to the vast expanses of space.